Hello, everybody. Good afternoon, one and all. I welcome you all to this afternoon session on the penultimate day of our school for data privacy. Professor Srinivasa is going to give the talk for this afternoon. Nikhila is going to introduce the speaker. Nikhila, over to you.
Good afternoon, all. It's my pleasure to introduce Dr. Srinivasa. Dr. Srinivasa heads a web science lab and is the Dean-R&D at IIIT Bangalore. He holds PhD magna cum laude from the Berlin-Brandenburg Graduate School for Distributed Information Systems, Germany, and MS by Research from IIT Madras and BE in Computer Science and Engineering from the National Institute of Engineering, Mysore. He works in the area of web science that models of impact of the web on humanity. Technology for educational outreach and social empowerment has been a primary motivation driving his research. He has participated in several initiatives for technology-enhanced education, including the VTU EduSat program, the National Program for Technology-Enhanced Learning, and an educational outreach program in collaboration with Upgrad. He is a life member of the Computer Society of India. He has served as a technical reviewer for various journals like VLDB Journal, IEEE Transactions on Knowledge and Data Engineering, and IEEE Transactions on Cloud Computing. He is also recipient of various national and international grants for his research activities. I welcome Professor Srinath. Over to you, sir.
Thank you, Nikhila, for a good introduction, and good afternoon, everyone. Firstly, it is nice to be back here at the TFOCS summer school. I remember many years ago, I think almost 4 years ago, I had given a talk in this school in the first edition of this summer school program, and it's good to see this school kind of growing over the years and becoming more and more popular. And I also am very gratified to see that there's a lot of participation, especially over the remote setup. It's easier to have good participation from a wide range of institutions across the country. It's my privilege to be talking to all of you. So, as Nikhila was mentioning, my interest. So let me start off this way. I was telling earlier as well, I could not really get time to completely finish my slides, so I may have to kind of partially talk, extempore and partially refer to my slides. So as Nikhila was mentioning in her introduction, part of my main research interests include an area called web science. So we're trying to understand how the internet and the World Wide Web is shaping our society. So it's not so much about the technology behind the internet and World Wide Web itself, but what is the impact? What kind of impact that it is making on our lives in general, right? And so in this regard, we have been taking up different kinds of research projects. And so what I'm going to be presenting today was partly part of our project, which we did with the University of Aberdeen in Scotland. This was so we started this project sometime in 2010 and we finished sometime in 2014 or something. So this was a project meant to use web-based technologies for sharing medical health records or other kinds of sensitive information, safely in an open-ended fashion. So this was one of the things we had kind of I wouldn't say pioneered, but we were one of the early ones to kind of look into this. Today, of course, you see EHRs, electronic health records, and and the way they are going to be managed is getting more and more streamlined, right? We are having some standards coming up, and DEPA is India's own standard for managing data empowerment and protection architecture, right? And so there are a lot of such standards coming up for managing or sensitive data, especially personal data, that we can share in an open-ended fashion. So, right, and so my talk, like I said, is about how do we manage consent in such setup, right? How do we manage consent when we exchange data? Okay. So I'll give a little bit of overview of the idea of consent management itself, and then we'll look at some of the emerging standards that are coming up, and then I'll propose or I'll present our own proposed model, which we have proposed in the context of EHRC earlier. Now we are trying to implement it in the context of smart cities in collaboration with IUDX, who will be giving the talk tomorrow, I think, in the Indian Urban Data Exchange. Okay. And of course, please feel free to ask any questions anytime during the chat, and I can have little pauses during the presentation, so we can take up some questions along the way. Okay, so so just to talk about, so let's look at the idea of consent management itself. So we'll start with the concept of data ecosystems, right? So this is a concept that is kind of getting more and more traction these days. That just like we say, no man is an island, right? And humans are generally social creatures, and it's only when human connections develop, something can emerge out of this, and so on. The same thing can be said about data as well, right? No data is an island. So a lot of us generate a lot of data. Some of it is personal, some of it is non-personal, but really the utility of the data. So if we want to utilize the data and use it for some purpose and so on, it typically needs to be combined with other forms of data and used in some form, right? And so there is an increasing push to leverage, isolated data sets to be shared and combined with other data sets for some kind of overall greater good, right? And so as we, especially with advances in, say, IoT, or basically ICT in general, right? More and more data is getting generated. The camera feeds, the demographic data, economic data, pollution data, transport data, all kinds of data sets. And how do we kind of start using them together? So this is the idea of a data ecosystem. And of course, as you know, with any ecosystems, so there are desirable connections and there are undesirable connections, right? And so not all kinds of sharing of data is desirable. And of course, this leads us to issues of security, privacy, and so on. Right? So privacy protection and consent management suddenly now become the primary building blocks or primary areas of concern if we have to build any kind of data ecosystem, right? And there are quite a few, like I said, now quite a few of these things are getting formalized. These kinds of ideas are getting formalized. In India, at least, DigiLocker is one of the pioneers in this area, where it gave you a secure locker space where you could store your personal data. And now DigiLocker is also coming up with interfaces and APIs where you can give consent for other third party to use your data, right? And so, for example, today, if you open an account with a stock trading app, for example, right, like say Upstacks or Zerodha and so on, right? And so you need to do your KYC. That's a legal requirement. Now, with DigiLocker, what you can do is you can give DigiLocker access to, or you can give Zerodha or Upstacks access to your DigiLocker, so that they can have access to your Aadhaar card and then verify your KYC details, and so on, right? And so you don't need any kind of running around with form to be filled and say, attested, signature, and so on. Just sitting in the privacy of your home and so on your mobile phone, you can actually finish your KYC, right? And so there are already such kinds of a lot of progress happening in this, and this is an example of data ecosystem, right? I mean, there's data somewhere in one place, and it is getting utilized in some other place for a greater good. Right? So, so in order to build data ecosystems, so how do we kind of build data ecosystems and so on? There are a lot of these, there are basically two major paradigms that came about, right? And to help explain this, I will also bring in an analogy. If you are familiar with web application development, right? And there are two broad ways in which you can maintain state in a web-based interaction. If you know, HTTP is a stateless protocol, right? I mean, if you send a HTTP request for getting a web page, the next HTTP request will have no information about the previous request that you sent, right? So that is what is called stateless. Okay. So how do you manage state in a HTTP request? There are two broad paradigms, right? And one is what is called the RESTful paradigm, where the client, that is you, is entrusted with something that is it is your job, right? So it's something like you go to a hospital and they open a file for you, right, in order to keep a record of what all happened, but they give the file to you, right, and it's your responsibility to take the file back to you, to the hospital next time, right? And so that is one kind of approach. The other kind of approach is a session management, right? And, where the hospital itself has a set of lockers, and they deposit your file in there. And whenever you go there, you don't have to take anything with you, but they go and get the file from you, right? And so these are two broad approaches to session management. The same is true for data ecosystems as well, right? So one is, the whole responsibility of sharing the data is with you. You can perhaps, for example, host the data on your own web server, and then say, okay, these guys can access it and so on, right? And so that's one, but that's not very. That becomes a nightmare when it comes to managing consent, privacy, and regulations and so on, right? Because as we go along, there are so many regulation changes that are happening, right? And there are new privacy laws that are coming up. So Europe came up with the GDPR. India also has its PDP Act, and quite a few other countries has its own regulations. And to enforce these regulations across the board on personal web servers is going to be very difficult, right? And so that's why there is the emergence of another entity called intermediaries, right? So data intermediaries, which are basically trusted entities in which you can host your data and then share it with others based on your consent and applicable regulations, right? And so this is the idea of data intermediaries. Sometimes they're also called data trusts, right? And they are basically emerging as an important element of data ecosystems. And data ecosystems, like I said, are being proposed in so many different application contexts, right? And in order to understand the role of data intermediary, or why data intermediaries are going to be significant, we just need to look at maybe 100 years ago, right? A little more than 100 years ago, right? So up until 100 years ago or so, people around the world literally, stash their wealth and money in their own houses, right? And so they kept their wealth sometimes even buried in the ground and so on, right? And because they could not trust any other external entity to manage their wealth for them, right? And but today, if you see, we keep just about all our wealth in a third-party institution, which are the banks, right? And so we keep not only our salary data, we keep our jewelry, our all other valuables, everything, with in bank lockers these days, right? In fact, we don't trust that we will be able to keep our wealth safe, and we trust the institutional mechanism, which is the bank, much more than we trust ourselves, right? And so a similar thing is also true for data ecosystems, that more and more it's becoming very difficult for individuals to kind of comply with the increasing requirements of data sharing, and resorting to third-party kind of institutional mechanisms, which are data intermediaries, in order to manage their data sharing for them, right? And compliance with applicable regulations, right? So basically, an intermediary sits between the data owner and the data requester, and it is also kind of there's a regulator or regulation authority which oversees the operations of the data intermediaries. Okay, so this is and there are quite a few reports that are coming up, and quite a few articles on data trusts and data intermediaries. Of course, as you can imagine, just like banks today are extremely powerful, right? In fact, some of the wealthiest people and some of the most powerful people are bankers, right? And same thing is likely to happen with data intermediaries, because they hold so much bargaining power, right? In fact, you can put all your data, let's say in DigiLocker, and not even worry about paper certificates, and suddenly one day your DigiLocker you don't have access, then what happens, and so, right? And so they are actually very powerful, but they're also very key to ensure digital agency and privacy. So here are some recent reports from the World Economic Forum on the importance of data intermediaries, and why data intermediaries are going to become an integral part of a data-rich society, that we are going towards. Okay. So they do have a lot of bargaining power, and they do have a very very central location to play, and but of course, which is all the more reason that they have to be really tightly regulated, from by law. So, yeah, there is a comment on chat which showed this as similar to escrow in the financial world. Yes, that's true. So a lot of escrow accounts are also they basically keep your wealth in trust and then share it with others or give it to others based on your instructions and applicable regulations. Okay, so here are some data intermediaries that are coming up. Indian Urban Data Exchange, which is what we are working with. There are some open data initiatives, which are not exactly data intermediaries, but yeah, you can think of them as intermediaries for open data, not for sensitive data. DigiLocker is there. Recently, there's one more, something called eva.care, which is an app which you can download, and you can maintain all your medical health records over there. And more doctors are basically getting onto eva.care. And that's another example of data intermediaries. And so, right. And now, the main problem, of course, in such a mechanism is how do you manage consent, right? And privacy. So I'm going to nitpick a little bit. I know this is summer school on data privacy, but my talk is primarily on consent. And consent and privacy are very closely related, right? But they're not the same. Okay, so we are going to nitpick a little bit on the difference between consent and privacy, or consent management and privacy management. And consent management is also very closely related to access control. So we'll also try and compare contrast between consent management and access control and so on, right? And so these exchanges need to be very highly specified in these in the intermediaries. So basically now, what kind of constraints can we in a very broad sense can we kind of categorize the kind of constraints we have on the way data is getting used, right? In any intermediary, right? And so if you see broadly, we can think of three classes of constraints, right? So I'm calling them as availability, consent, and security, right? Three classes of constraints. Right? So how do you kind of how do you define or how do you understand these constraints? you understand these constraints by focusing on who is the opposite of beneficiary. That is, who is the victim, or who is the one that stands to suffer, okay, if this constraint is violated. So, right, and so for example, let us say availability of a data set. So some data set needs to be legitimately available, but for some reason it's not available, right? And so if I violate availability constraint, then the data requester is getting affected, right? So abstracts basically wants to verify my KYC from DigiLocker, but for some reason availability constraint is violated, right? And so DigiLocker is down, or it got access, and so basically abstracts is the one that gets affected, right? And similarly, if consent is violated, okay, then the data owner is the one who is affected, right? That is, if somebody shares my data without my consent, then I stand to get adversely affected, right? Somebody may get my private information or something that is very unique to me, and I may get adversely affected. Okay, and security, if it is violated, then the system as a whole is affected, right? So some kind of systemic, like for example, national security or something, is leaked through something, then the system as a whole, the ecosystem as a whole is affected, right? And so broadly, we can basically think of three classes of constraints: availability, consent, and security, right? And primarily in this talk, we'll be focusing on consent. That is, when this is violated, the primary affected party will be the data owner, right? But of course, this whatever we build needs to operate along with availability and security constraints, right? And so, see, one way to ensure that none of your private data is leaked is to never share your data at all with anyone, right? So I take your data and never share it with anyone at all, right? And then your private data will always be safe, right? But then it's going to violate the availability constraint, right? And you can't do anything with it, and so on. So we need to basically manage consent, keeping in mind both availability and as well as security in consent. And in addition, of course, the property of the data itself, right? In recent times, there have also been a lot of initiatives on what are called open data initiatives, right? There's something called data.gov.in from the central government, which is an open data initiative. From Karnataka government itself, there's something called CODI, Karnataka Open Data Initiative, and so on, right? And so there, we had very similar concerns over this, and this was also kind of addressed in a very similar fashion, where they're talking about transparency, privacy, and security. So, right? And so transparency is where some data should be shared publicly in order to kind of promote transparency in policy making and democratic process and so on, right? And if transparency is violated, then it encourages corruption or something, right? And privacy is something again where the individual users may get affected if privacy is violated, and the collective security, like national security and so on, or institutional security could be violated if security constraints are violated. Okay. So, so broadly, we talked about open data, right? So open data is where data that promote transparency, that can be shared openly and so on. And the opposite of open data is, we talk about as closed data, right? Where data needs to be kept secret. There are some shared secrets, like say passwords or PIN numbers or some access keys and so on, which are closed data, which shouldn't be shared with others. The OTP that you get and so on. Right? And so this is the opposite of this one. But then there's a third class of data which we call as open-ended data, right? So open-ended data typically, but not necessarily, concern some kind of private data, some kind of sensitive data, but which are not exactly closed data, in the sense these are private data, but we still need to kind of exchange it in an open-ended fashion, right? And so this is what we are defining. That data need to be shared in an open-ended fashion, but not openly, right? And so this is another nitpick that we are going to do. What is meant by open-ended sharing and open sharing, right? And so open sharing means that anybody can access my data, right? Open-ended sharing, I think I have a slide here. So what does open-ended means, right? And so open-ended means that I share my data in a way that that I may not have knowledge or control of how it is disseminated. Okay, but I know that it is going to be disseminated in a controlled fashion according to a policy frame. Right. So, for example, if I share my PAN card details, if I share my Aadhaar card details, right, and I don't know who all will get to see it, right? So I share my, the bank will ask me for my KYC details. I give my PAN card, I give my Aadhaar card, and so on. I don't know who all they will share it with, right? And I may not even have knowledge. I may not be able to control, but I know that there are certain regulations in place and enforcements in place. So I know that this is not going to be shared in a regulation-free fashion, right? It is going to be shared in a regulated fashion, but I may still not have control on how it is shared. Right? So this is what we call as open-ended data, right? And so the problem of consent management primarily has got to do with open-ended data management, right? We don't have consent management for open data or closed data is a different thing. You don't have to share it at all in the first place, right? And, so this is the idea of open-ended data, the kind of data that we want to share. Okay, so yeah, I hope I'm kind of making sense so far. Yeah, I think there's one more question on the chat. Can we call forensic evidences as open-ended data? Is like CCTV footage? Very good question. Yeah, I guess because some kind of evidence, they've got some forensic evidence, and they may need to share it with different agencies, right? And different agencies may actually even in a way that they may not be able to control. In some sense, if forensic evidences are more tightly controlled, like say, unlike say Aadhaar card or, and so on, right? And because it's kind of treated like closed data that is, on a need-to-know basis, it's kind of shared and so on. But yeah, I mean, they are of course shared between agencies and according to certain regulations. Here, what happens is in open-ended data specifically, I as an individual may be may not be strong enough to enforce. See, if somebody takes away my data, takes my PAN number and so on, how will I go behind them and enforce it and so on, right? So I may have no knowledge or control, but still I know that there is a framework or there is a regulatory system in place that can ensure that this data is kind of getting shared in a legal fashion or valid fashion. Okay, there's one more question. Yeah, I think this is a good time to pause if there are any questions. 1 minute, let me. Oops. So the screen is kind of. Is there a benchmark that this is where segregation of data is as open or open-ended or closed once by the companies, right? Yeah, yeah. As always with any benchmarks, right? The boundary is gray, in the sense, of course, we broadly define the difference between open-ended and closed. But really now, when we come to say policy-based consent management and so on, we'll see that the boundary is kind of not strict. Right, so it depends on the policy around this thing, right? What we consider open-ended and what we consider closed, and so on, right? So I'll so hold on to this question. I'll talk about open world and closed world hypothesis or open world and closed world paradigms in a moment, right? And so that can give us an idea of the difference between open-ended versus closed, right? Okay, good. So, earlier I also mentioned that privacy and consent are very closely related, but they're not the same, right? And let's see how they're actually not exactly the same and so on, right? So I'm sure you attended a few more talks earlier in this summer school on, say, differential privacy and even, say, homomorphic encryption, right? And a secure multi-party communication and so on, right? And so the moment you talk about privacy, you talk about encryption, you talk about, can I deduce what is there in the data without, and which will say, which will basically tell me whether privacy is violated and so on, right? And so if you see, privacy is basically a function of the data itself, right? Whereas basically what the questions that privacy answers or privacy preserving models, they basically answer is, can I infer what is there in the database based on what you're showing me, right? Let us say you have encrypted the data and shown me, or you have anonymized the data and shown me, but I can still see some patterns in the anonymous data or in the encrypted data, and I can probably infer what is there in the database, right? And so that privacy preserving architectures kind of address, right? And of course, homomorphic encryption basically says, can I make computations on anonymous data in a way that you can never infer what is the actual data, but still I can do the computations. Okay. In contrast, consent management is a function of the data owner and requester. It's not about the data, right? Consent management basically says, who does this data belong to, right? Whom should you ask for permission to use this data? Who can ask for permission, right? For what purpose can they ask for permission, and so on, right? And so primarily the object of focus here is the ownership algebra, right? How is the data ownership established, and so on, right? And so there are a lot of complications that come in. For example, things like somebody comes and says, I want to buy Vidhan Sauda. Can I buy it from you? And I give consent, saying yes, you can buy Vidhan Sauda. So you see, you can't really. Why? Because I don't own Vidhan Sauda, right? And so that is really the consent management. Who can give consent for what, and who can ask consent for what, right? And that's the difference between privacy and consent management. Okay, there's one more question. Okay, my voice broke while in consent and privacy. Okay, yeah. So because this is one of the key concepts, let me again repeat once again. So how is privacy management and consent management different, right? And so privacy is actually about the data itself, right? So privacy management addresses questions like, can I infer the contents of the data by looking at patterns in whatever I am shown, right? So maybe I am shown only a sample of the data, but from the sample, can I infer the complete data set? Okay, or maybe I'm shown an anonymized set of data, but there's still some patterns in the anonymized data set, and maybe I can still infer what is there, right? And similarly, I'm shown some encrypted one, but I can still infer, right? So that is the main challenge question, right, in privacy. Okay, but in consent management, we are not talking about the data, but we are talking about the data owner and data requester, right? And so we are talking about who does this data belong to, and who is authorized to give consent, and who is authorized to ask for this data, and in what capacity they can access ask for this data, right? And so this is the difference between privacy and consent management. And we see, of course, there are some complications that appear when there could be some confounding cases where privacy and consent can clash, right? And for example, let us say a reporter takes a picture of a public gathering that shows many other people in the picture, including some people who wished others to not know that they're attending the gathering, right? And so a reporter takes a picture of some protest march or something and publishes it somewhere. And so now who does the picture belong to? right? So the reporter says, I took the picture, but therefore it belongs to me. And the person in the photo says, you took picture of me, and and because it's of me, I have a say in saying whether you can publish this photo or not, right? And so this is the kind of thing that comes into consent, and that where you see a clash between consent and privacy, right? And similarly, this one, right? Another example: an institution runs several academic and research programs. So let's say I'm and also host students in hostels and so on. And the institute performs an annual data audit where we look at all the data from all the labs and programs and everything, right? And to see that everything is in order, there's no illegal data that's there, and so on, right? And so, given this, am I also authorized to access and audit any personal data stored by its hostel residents? Let's say we have a data bank or a cloud server, and some people store their personal photos in there. So am I authorized to access it? Because it's of the institute, right? So, or the other way, other question I also keep saying is: suppose I am the director of an institution like ours, and so right, and so I'm kind of the boss of the whole place. So I can walk into any classroom, any lab, and so on. Nobody's going to stop me, right? And but can I walk into anybody's hostel room, right? And so on, right? And so ownership and privacy kind of clash where when it comes to personal data and so on, right? And so that brings me to this thing called the data ownership continuum, right? So how do we kind of think about data ownership, right? And how do we kind of say how the where do we draw the line in some sense, right? And so if you see, data ownership has a big continuum, right? So data can be owned by individuals or families, right? So there could be genealogy data, property data, albums, and so on, and it could be owned by, say, communities, institutions, government, public, and so on, right? And that's a complete continuum of this thing, right? Now, in this, you can actually draw a line somewhere here, right? And see that this part here is where consent pertains to privacy, right? And this part here is where consent pertains to security, right? So let me kind of repeat that once again. This part here primarily pertains to data of a private fashion, an individual's private data, family's private data, and so on. And if we violate consent, it is these individuals or families that get affected, right? And that's where the the consent management kind of addresses here. Yeah, but at the same time, we also have institutional data, right? IIITB has its own data sets, and there could be some resident welfare association, there could be some trusts and convents and societies. And, they have their own data, right? And so these are what are called non-personal data, right? And here consent basically pertains to the institutional security in place, right? If I leak some institutional data without consent, the institution as a whole might be at risk, and so on. And so this, in fact, India is one of the few countries that makes a distinction between non-personal and personal data, right? In fact, if you look at Europe's GDPR, it basically has a general data protection regime, right? It has generalized rules about data protection, while in India we have separate rules, one for PDP and one for NPDP. One is the personal data protection law, and the other is non-personal data protection law. And so there are two different kinds of. So this is what I was kind of trying to come to. So there are quite a few regulations that are coming up around data protection, including consent management. And EU GDPR is one of the very well-known regulation, which has several, I'm just putting some highlights on this. For example, right to access, right to be forgotten, privacy by design, and so on. There's also something called American Data Dissemination Act, ADD, and which extends what's called the Privacy Act of 1974, and then goes further. And I was talking about India, and in India we have two different acts. It's not completely an act as yet. So the personal data protection is already part of the law, but non-personal data protection is, as far as I know, it's currently a bill which is not yet passed into law. So personal data protection pertains to these kinds of, the second part of this, which talks about individuals and families and so on. And privacy constitutes a major chunk of this. And then there are non-personal data protection that talks about communities and institutions and so on, right? And where the security of the institution or integrity of the institution becomes the primary concern. Okay, so and currently, of course, although earlier the earlier version of this work, addressed something called medical health records and so on back in 2013 and so on. We were actually talking about personal data, okay, but currently we are focusing mostly on non-personal data and how do you kind of manage consent management in a non-personal data protection framework, because personal data protection it's way more detailed now. Way more things have come into place and way more compliance requirements. So for non-personal data protection, at least in the Indian NPDP scene, there are certain roles that are specified. And I'll just go through this so that the terminology, so that it becomes easier once we kind of explain further. So community is basically the non-personal data owner, right? So group or organization or institution, right, which is the owner of the data. So that is called community in this case. And the community is said to appoint a representative who is called the data custodian. The single point of contact. So the data custodian is basically represents the community in different other scenarios, and data trust is the intermediary, right? So which hosts the data of the community in trust and so on. And sometimes they may outsource some data processing to a data processor somewhere, right? And I've not included data requester. So some of this data may be requested by a data requester as well. Like for example, abstracts, I said, right? Abstracts wanting your PAN card data and so on. So from the data trust, sometimes the data trust can also outsource. For example, your bank can outsource all your financial transactions and so on to a third-party data processor in order to process or give some analytics and so on, right? So they are called data processing. Right? Now, all of these are controlled by what is called the NPDA or the NPD authority, Non-Personal Data Protection Authority. So this is what the bill primarily proposes, that establishment of a non-personal data protection authority that kind of oversees the regulations around this, and anyone who wants to share data will need to have a custodian in place, and they have to represent the community and so on. Okay, so I think I'll skip these two slides, which might be a slight some more deviation of how to characterize utility and so on. So this is primarily how we kind of think of this. Okay. Now, before we go on to consent management architectures itself, I also mentioned that consent management is also closely related to access control, right? And so why? Because my consent is primarily about access and the data, right? And who gets access and on which data, right? So that is the two variables that I'm basically controlling, right? And in order to say who gets access, right, there are again different paradigms, right? What do we mean by who and so on, right? And so again, we'll see different kinds of paradigms coming up here, right? And the most common paradigm is the identity-based access, right? That is, I basically give a consent for a particular user, particular person, based on their identity. That is, they basically say, this is who I am, right? For example, say Shyam here. Right? So I give my access only to Shyam. So he should prove that he is Shyam before accessing this data, right? And so this is one of the more widely used paradigms. A second paradigm that is becoming more and more common, especially now with so-called Web3, right? It's also called the token web and so on, right? Which is basically a key-based access, right? So key-based access has also been there for a while now. For example, applications. So if you if you want to access the Twitter API, for example, to get some data for yourself, right? And you have to first create an application key. You have to register your application. They'll send you a key, and you have to give the key, and then you can access the data. Right? And so this is the key-based access. Anybody who has the key can access the program. Okay. But of course, with identity-based access is tightly tied to individual agents, and it may not be easily transferable or delegatable. So if somebody from, say, Axis Bank wants to access my data, I want to know exactly who it is in Axis Bank that's going to access my data, right? And on the other hand, if I give a key, generic keys can run the risk of being stolen. So if I've stored my application key in my machine, and somebody reads the contents of my machine and uses the key, then it can access, right? And keys don't directly capture what is the policy or legal capacity in which a data is. I have the key, I get the access, right? Why am I accessing the data? Under what legal capacity I'm accessing the data? That I don't have. A third kind of access control paradigm, which has been there since the 90s and so on, is what is called role-based access, also called RBAC, role-based access control. Okay. This is primarily used within an institutional framework. So within an institutional framework, what we do is we create different roles, right? So let's say in an institution like, say, IIITB, we have roles like faculty member, staff member, non-teaching staff, adjunct faculty, student, research scholar, all kinds of, right? And then give different kinds of privileges to each role, right? Now this role can do this, this role can do this, right? And so what this does is it creates one more level of indirection between individuals and the data, right? And so the privileges are not associated with an individual, but with the role, right? And there is a degree of freedom between individuals and roles. So individuals may be assigned to a role, removed from a role, and reassigned to somebody or some other role, and so on. You can also access given data from different roles, right? I mean, for example, a doctor can be a patient in its own in the same hospital, right? And so when you access data as a doctor versus when you access data as a patient, then you have different credentials, right? So this is the role-based access control. Now, role-based access control typically is defined and enforced within a larger institutional context. So there is basically a role granting authority which is there, which grants the roles and then enforces the privileges and constraints for each role. And so, okay. Now that becomes again difficult when we talk about data ecosystems, right? When there are multiple institutions involved, right? So let us say IIITB is one ecosystem. There's part of the ecosystem. There's some other institution, Infosys is there, IISc, so many different institutions. Now each of these institutions have their own roles and their own role enforcement mechanisms and so on. And so this becomes difficult to export it to a data ecosystems kind of environment. Right? So that is where we are getting more and more what is called as policy-based access. Right. So for policy-based access, what we do is we create what is called as a legal capacity. Right. So when let us say one institution and another institution want to collaborate, right? Legally, what we do, we create some kind of an MOU, right? And we create an agreement saying that, okay, we agree to work together on this, and so on. And then in that agreement, we create some kinds of what are called role tunnels for legal capacities. That is, somebody from here is authorized to come here and do this work, right? That is, somebody who is playing a role over there will be given or granted a corresponding role here. right, and the corresponding set of privileges and so on, right? And so this is the kind notion of policy-based access control, where there's a policy within which a different institutional contexts can be, can talk to each other and then create a pathway for data flows. Okay, so there's one more question, so let me pause again and. Okay, the question is the primary intent of a key-based access privacy? Yeah, well, key-based access is yeah. I mean, SSH. Wait. So there are two kinds of keys over here. The SSH key is basically an encryption key, right? And there you have a public-private, public key and symmetric key encryption and so on, right? And so basically, the idea of the key SSH keygen, if you use, that is used to encrypt the data. So this is the key that is used to kind of encrypt this and so on. Okay, but the access control keys are more like application tokens, right? So what I mean is, if you, like I said, gave the example, right? That if you want to use Twitter API to download their social media data, right? So you first have to register your application, and it'll generate a random key for you, right? And so that random key is your primary key in the records, saying that, okay, this key means this application, where you would have given some details about your applications. So that is the that's what I mean by key-based access control, where it's actually about access control. Good. So let us now look at a few policy-based access paradigms that are coming up. And like I said, India is one of the front runners in this area with what is called as the DEPA architecture. So DEPA stands for Data Empowerment and Protection Architecture, right? And this primarily what this DEPA document basically talks about is how do we enable users? So that it basically recognizes that there are so many users who are creating digital footprints today, especially with mobile payments and so on, right? Even before they even start becoming, say, income tax payers or whatever, right? A lot of it's also what is called as ARPU, average revenue per user in a business context. So even very low ARPU users now have a digital footprint, right? And so DEPA basically says, how can you enable users to take more ownership of the digital content and then give access based on consent, right? And it's a pretty detailed document. I won't go into it in detail. So basically, it proposes something called as a consent manager that sits between information users or the requester and the provider, which is there, right? And so the user basically has their data among different providers in their banks in so many different places. And the consent manager sits in between them and informs the user or takes their explicit consent in some place, and then sends the request for data and then shares it with the user, right? And so this is a typical DEPA consent artifact. If you can see, this is how the ontology of a consent looks like in the DEPA system, right? Where you have an identifier section saying who is the collector, who is the consumer, who is the owner, right? And as you can see, data now ownership is through identity as well, right? And so same thing with collector and consumer. You're basically identifying collector and consumer by identity, right? This is the collector whom I want to, and of course this is the data section that is for on what do they have consent, for how long do they have consent, and for what purpose, right? So here there is a purpose section here. So this is for loan purpose and so on, right? And, so this is how a typical ontology looks like for consent in the DEPA architecture, which is now, one main issue that we see primarily here is, we'll come to that. How do you kind of encode policies into these kinds of consent artifacts which are there, right? And so another this one another related framework is what's called Solid. So Solid was created by Sir Tim Berners-Lee. So he was one of the primary creators of the World Wide Web protocols itself, HTTP, HTML, and so on, right? And so Tim Berners-Lee had started this movement called re-decentralization of the web, right? And so basically, he was concerned about how much of our personal data is being stored in centralized third-party apps like, say, Facebook or Google and so on, and how much control they have on our personal data. And we are just given a legal document, and you have to click on I agree, otherwise you lose everything. So, right? And so how do you give more power to individuals for their own data, right? And so this is where he had proposed a pod-based system called Solid back in 2015 or so. So basically what Solid does is it stores data in decentralized secure storage units. They're called pods. So all our data will be stored in our pod. And we can share data between pods based on the identity of the pod owner and data request. So everybody is given what is called as a web ID. And based on the web ID, I can give access and then give consent, right? And so this is also mostly based on identity-based access. So pod is somewhat popular, but it's not exactly, it didn't really take off so much as it was expected earlier. So there are a few other research frameworks, Advocate, Consensio. I'll kind of Advocate, for example, again uses Hyperledger and blockchains. They're all used for basically bookkeeping and ledger management and so on. But primarily in terms of policies, they use they use an RBAC based approach, Consensio, and this one again uses identity based approach and so on. Okay, so coming to so this is all primarily what is the state of the art currently, and I'll use the next I still have some time, so maybe next 10-15 minutes to basically talk about what is the approach we are taking to for consent management approaches and so on, right? And so the approach we are taking up is like I said, there's so many issues that are involved, right? So there are already lots of efforts on, say, smart contracts and key management and so on. But how do we bring all of these together, right? So one is if I have if I have to take consent explicitly on each and every data access, right? It might be very difficult, right? So that's why we are going for a policy-based access. So can I implement a consent policy, and based on which I can guarantee certain things, and and this policy should be within something called as a regulation, right? So basically, our proposed approach has 4 different layers like this. So there is the regulation layer, which talks about what are the regulations governing data exchange. Who can ask, who may not ask, which can override even my consent, right? And so that's the regulation layer. The second is the policy layer. So policy layer is where the data owner specifies a policy, saying that this entity can access this data for this purpose for this long and so on, right? And so this is the policy layer. The third layer is the contract layer, which basically enforces both of these put together, right? So these are what are called SLAs, right? The service level agreements. Right? So at the time of data access, when you are trying to access something, the contract layer comes in and says, okay, is this according to policy? Does it violate any regulations and so on, right? So that's where this thing. When all of these kind of match, you get into the key management layer. Right? So the key management layer basically generates a key for you when you satisfy all of the previous layers, this thing, right? And so it has to somehow ensure that if and only if this is the case, then I generate the key for you. So this is how we kind of broadly look at. So what I'll currently talk about will be mostly the first 2 layers. And the second 2, we are still, working on some of this. And so first 2, we already have published. So I'm more comfortable talking about these 2 kind of right? So the first thing what we come to is, okay, now how do we specify policies, or how do we model policies, right? In a computational form, right? In a form that is readable by computers and understandable by computers, and so on, right? And, so which is where both policies and regulations, of course, right? And so what we do is we first take regulations. So regulations and policies, that they're both written in English, basically, right, or legal English, right? So in legal terminology and so on. Okay. Now we first take that and convert that into some kind of formal statements or formal assertions, formal what are called deontic assertions, right? With certain modalities, right? So I've just given different colors for each modality. I'll talk about that in a moment. The simplest modal logic is, deontic modal logic is what we call OPF logic, right? So OPF stands for obligations, obligated, permitted, and forbidden constraints in the policies. Okay. And then we break it down into that and give it to the policy layer. And the policy layer in turn has different domains, or also what we call as worlds, which has its own policies in there, and it combines the regulations with the policies under each domain, right? And so this is how the overall structure basically looks like in this. So what is so what's an example here? So let us say a regulation says that every person should file their returns, or should upload some kind of an access log or something like that, about their data and so on, right? So now that becomes a obligation, right? So you should file your returns, you should do this, you should do that, and so on, right? And so that's an obligation. Okay. On the other hand, you may do something, you may do this, you are entitled to do this, you have the right to do something. Now all those becomes permissions, right? So you have a right to say something, but doesn't mean you have to say it, right? You may or may not say it. It's up to you, right? Similarly, you shall not do this, or you may not do this, or you're forbidden to do this. Now those becomes prohibitions and so on, right? And so deontic logic primarily looks at assertions like this. So for example, if I say something like OA, right, it means that A is obligated and so on, right? Similarly, if I say PA, right, so PA basically means P is permitted. So, sorry, A is permitted, right? So where A is any predicate or action, right? So if I say this action is obligated, it means that I have to do this action. Right? And if this action is permitted, it means that that action is available. You can click on it, or if you don't want, you don't have to click on it. Right? And and how do we understand how these different modalities react? So we see some quick axioms over here. So for example, if the regulation says A is obligated, okay, but I see that A is not true, right? Then it leads to a contradiction, right? That means there's a constraint violation. If it resolves to F, it's a constraint violation, right? Similarly, if A is obligated and A is true, then there's no contradiction. Right? It is true. Okay. Similarly, if A is forbidden and it is true, then it leads to contradictions. Okay. And we can put negation now in different places and see how it also looks like. For example, if I say not A is obligated, right? That is, the negation of A is obligated. It means that A is forbidden. Right, that is, it is obligated that A shall not be true. That means A is forbidden to be true. Right, and similarly, it is not obligated that A shall be true. If that's the case, it means it is permitted. It's still permitted to be true. Right, so A is not obligated to be true, but it's still permitted. So you're not obligated to carry your own lunch to office, let us say, but you are permitted. You can still carry your own lunch. Right? And similarly with PA, you see any of these leads to PA itself. P of not A also is PA. You are permitted to not do this, means you can still do this, right? And so on, right? So I won't go into all of these axioms, but this kind of forms the basis on which we kind of reason on how a particular policy is interpreted. Okay. And finally, this comes to, I think there was one earlier question, and where I said I'll hold on to this question and I'll come back to this, right? And, so the question is, yeah, how do we distinguish between open data and closed data? Where to draw the lines? Okay. Now that brings us to what's called open world semantics and closed world semantics, right? So let us say I have a domain or a world, and I say it's an open world, right? And so what do you mean? So let's say that I have an assertion which may have one of three modalities: obligated, permitted, forbidden. Okay, but somehow there is some assertion on which nothing is said. It's neither said it's obligated, it's neither said it is forbidden, neither said it's permitted, right? The regulations doesn't say anything about this, right? Then what do we see? Right? So in an open world, if I say nothing about an assertion, it means that it is permitted, right? So if I say nothing about what kind of data you can share, or if I say nothing about what is something, then it means that by default everything is permitted, okay, unless it is explicitly forbidden. Right? In closed world semantics, it is the other way around, right? If I say nothing about something, by default everything is forbidden, right? F of A, unless explicitly permitted. Right? So you can basically think of two different paradigms, right? So if I'm having a closed data infrastructure, right, I'm basically working with closed world semantics, right? So by default, everything is a secret, right? Unless otherwise I permit something, right? On the other hand, if I have not so sensitive data and so on, I get into open world semantics by saying that by default you can access it, unless otherwise I say no, this is sensitive, you can't access this. And yeah, a few more axioms. I will skip this as well. We can go into this separately. Okay, so now based on that, I'll just come to the framework that we had proposed. Very similar to SOLID. In fact, we had proposed this even before SOLID was proposed. So SOLID has this concept of pods, and we have this concept called worlds. Right. So this earlier it was called many worlds on a frame, and now we are calling it a multiverse framework, right? And so how does this framework look like? So in our framework, you have many worlds, okay? So within which data is actually stored and shared, right? And there are some linkages between worlds. So the linkage pattern is what is called as the frame, right? And these linkages are driven by policies. So I gave this example of MOU between Infosys and IIITB, right? So basically there is a labeled edge between this and this, and which gives us the linkage that regulates how data can flow between this. Okay? So, and in addition to worlds and linkages, the frame, we have agents, which are users or application programs which can access data. And basically what we say is that each agent can also have its own world, right? So each application program can also have its own world. So it basically publishes data into its world, and then others can read it through the policy framework that we have created. And of course, a predicate is a property over worlds or agents, and an action is an action over worlds or agents or resources. And resource is a unit of data element that is accessed. Okay, so this is a more formal version of how this looks like. Again, let me not get into the nitty-gritties of this. So basically, I'll just talk about some predicates on which we can enforce modalities and actions. Right? For example, hosted. Right? Hosted R, W means that resource R is hosted in world W. Right? Now you can, on top of this, you can add things like obligated, permitted, forbidden, right? So for example, if I say obligated of hosted R, W, it means that it's obligated that resource R should be hosted in world W, right? And yeah, there's a question. Please explain frame. Yeah, so I'll come to frame here. So here also there is a more formal definition of frame. So frame is basically a set of connections between worlds, right? So how one world participates in another world, right? So that's what is called as a frame. I'll give some frame predicates in the next slide, which will make it more clear. Okay. So similarly, some basic actions would be like read or query, right, or write or something, right? So read RAWC, that is a resource, agent, uh, world, and token, right? Capacity token, right? And so resource R is requested to be read by agent A in world W using capacity token C, and so, right? And so then you can put P or F or O or something like this, right? And it means that it is permitted or forbidden or even obligated if required. Okay. Yeah. So this is again the same policy modalities term, so I can skip this slightly. Okay, so now let me come to the frame itself, right? How do we build these frames and how do we kind of go about building this? And again, of course, I also talked about open container, closed container, or open world or closed world, right? So, so not F of A, that is, if there's no explicit prohibition, then everything is permitted by default, right? In a open container or open world. And in a closed world, unless something is permitted, it is forbidden, right? And so this is the one. And within each world, you have a set of roles, right? Yeah. So there's a role table. I think I'll come to here. So similarly to RBAC, we have a role table where we say, okay, this is the role and these are the privileges. And these are all the players or agents who are assigned to this role and so on, right? And so you can basically specify a role, faculty member or student or whatever, right? And role R is played by agent A and so on. On the other hand, you can also specify a role using a third party. That is, you can say role R is played by any agent who is playing role R prime in world W prime. Right? That is somebody playing the role of R prime in W prime gets the role R here, right? And so somebody who is in this team playing this role gets this role in this. So that's the way you kind of get inter-world connections, right? So for example, let us say there's a individual who has a world, say Raju, and Raju plays a role in some world called XIIT and so on, right? And XIIT itself plays a role in some other world, say NIRF and so on, participating institutions, right? And now what this means is that the fact that I'm playing a role here, I can have some kind of access privileges on this link, right? In addition to resources, right? So the fact that I'm playing a role, let us say, I'm playing a role called outreach committee, something, a rankings committee and so on, right? A committee member will give me an access here and give me a role here in this, right? That means I'm representing XIIT here. Which is what it means, right? That I am going to be representing that world in the other world. Okay, so that is what is called as a legal capacity, right? The legal capacity is where I create a role here, and a role in the other world tells that somebody playing a role here gets this other role, right? And so that creates a tunnel, or that creates an interface between this and this, and creates what is called as a legal capacity from this, right? So from one to the other and so on. Right? And then on top of this, I can also have role constraints as well, right? So for example, I can have constraints of this form. If RA, then R prime B gets a modality M and so on, where M is OPF. We also use sometimes called one more modality called R for priorities. So I'll give you some examples here. So it says, this one says, if patient A, then forbidden of Dr. A. Okay, meaning what? Somebody who is playing the role of a patient in this world, let's say a hospital world, cannot also play the role doctor at the same time, right? If my patient role is active, then you can't also say I'm a doctor here and do something on yourself and so on, right? You should have a separate. Similarly, for many of us keep submitting papers to conferences and so on, right? If I'm playing the role of an author, I also can't play the role of a reviewer for my own paper, right? And there has to be separation between the two, right? So these are some kind of role constraints, I can say. I can also have obligation constraints. So I suppose I say I'm a research scholar, but I don't have an advisor, and so on, right? And so then it would be so every research scholar would have a advisor, research advisor. So if A is a researcher, then there has to be somebody who is called advisor in this work, right? And yeah, there's one more question. Can it be said as a role within? I'm not sure I got the question. Can it be said as a role within another? So yeah, I'm assuming that the question basically says, talks about the role tunnels or the legal capacity, right? And where I can give a role here based on a role that you play in another entity, and then it flows. So in some sense, there's a projection of your earlier role into this. So, but I'm using the term projection in a loose sense, in the sense of that you may not get all privileges that you have in your host organization, but you may have a subset or a different set of privileges here, based on the target organization. Right. So this brings me to the final this one. The concept of role tunneling, right? Now, when somebody accesses the data, right, and they actually access this data through several, gloves like this, right? And so for example, let's say there is some person, Dr. Ram, and he has his own world, let's say Ram, and then he plays a role in another world called, say, Fortis, in the role of a doctor, right? Now, this world Fortis plays, has an MOU or has a kind of a connection with another world called, say, Sharada, which is a clinic, right? Where it says that there's a role table here which says that anybody who is a doctor here can be an advisor here, and so on, right? So this role table basically says anybody who is a doctor and who is part of this referral list or something can play the role called advisor here. Okay, and this advisor here can have access to different data sets. Okay, now when this person accesses this data, basically what he's doing is he's coming through this tunnel like this. Okay, so from here it comes to here, here it comes to here, and so right. And so this is how this is where we come to the contract layer, right? That is, how do I kind of enforce a particular policy, right? That is where we have the right contract, right? So in a contract, so how does a contract look like? So contract basically looks like these things here, these elements. That is, I have to tell what action I want to do. So I want to say I want to read this result. Then I have to say in which capacity am I making the access, right? Now in the capacity, you see that I'm giving the complete role tunnel, right? So I am an advisor in this world, and I'm an advisor because I'm a doctor here, and I'm a doctor here because I am listed as a doctor. I am the owner of my own world, so I am me, and so this is an identity-based access. That is, and this is a role-based assignment, right? So this is an identity-based assignment. This is a role-based assignment. Okay, so this entire thing I give and say, okay, now this is the capacity. This is the legal reason through which I'm going to I'm asking for this data, and this is the purpose, the purpose code. So basically, what the policy of the target world. So the target world is a world called Sharada. So it will have something like, if somebody is an advisor, he can ask for this actions for this purpose code, right? Diagnostics or some verification, something, right? And analytics, and so there will be some purpose code for which. So you have to choose the purpose code for which you are making the access. So this is the contract layer where this is the contract that we will enforce. Okay, so that is broadly the kind of very broad overview of this work. So some of this work was implemented earlier. We had a system called RootSet, which we had implemented way back in 2013, 2014. Now, but that's a pretty old code base, and now we are trying to re-implement the whole thing refine some of the core terminology again in this. And there are also many more things to this which I have not addressed. One more thing which we are also working on is what's called risk modeling. So in risk modeling, the thing is, where we want to model what is the risk of allowing access by this roll tunnel and so on, right? And for example, in an ecosystem, I don't have an institutional oversight, right? Say I, as an institutional owner, I can probably know what is happening within my institution, right? But I don't know what's happening in some other institution, right? So for example, somebody says I am a doctor in Fortis, right? But then it may not be the Fortis that I think of. He may have created his own dummy world called Fortis and made himself the doctor. Right? So what is the legitimacy of this world, right? So there's a risk over there that I have created my own dummy a fake hospital, and in that I made myself the doctor, and then I've made this thing and so on. Right? So in order to verify this, I should verify the legitimacy of this, and I should verify the legitimacy of this and so on, right? And so this is the idea of risk modeling, and then I have to verify the legitimacy of this itself and so on. So risk basically balances out between, what is the threat in making an access versus what is the efficiency, right? And, so typically what happens is even in legal MOUs and so on, right? And so we say, okay, somebody has done the oversight, due diligence when the MOU was created. Therefore, I trust the MOU. So based on that, I'm going to do this. But the MOU may have expired and so on. Right? So all these kind of looks at the risk factors. So we are having something called risk factor, and can I, for high risk data sets, the risk factor, you'll do more checks, and for low risk data sets, you do lesser checks and much faster. So that's one. And finally, we are also implementing this as what's called as a consent service in this data exchange called IUDX. This, we are proposing this, so I'm not going to talk about this in much more detail either. So, okay, so that kind of brings me to the end of my talk. A few more this thing, in fact, the multiverse framework, we also compared it with requirements of GDPR and PDP Act, and basically it addresses quite a bit of the requirements in both of these: right to access, right to be forgotten, privacy by design, data protection officers, and so on. And similarly here, technology agnosticism, holistic application. So basically, we can go into this in more detail. So that's about this, and some of our own publications and some references which I'll be glad to share. So that brings me to the end of my talk, and I hope it was useful, and I'd be glad to take any questions.
Sir, thank you very much. That was a really wonderful talk. A lot of information, and I'm sure there's so much more that you have mentioned that is left on the table to be understood by all of us. Any questions from the audience? Professor has already answered a number of questions. If there are any more, I don't know if Maruti is mentioning about the summer school talks in general, or regarding Professor Srinivasa's works. But is there any forum that is there, sir, that people can access and for example, yes, sir.
Go ahead, please. No, unfortunately, not yet. I mean, this has been primarily our own internal research work so far, but definitely, we can. For my other talks, you can access our lab YouTube page. So I'll just give the lab address: wsl.iitb.ac.in. If you go there, there is a link from there to our YouTube page where some more of not just my lectures, but talks from our research scholars and other talks are also there. So it might be of interest. Thank you, and I guess that answers the question. I think it was great to be here, and very good questions and interactions that came up. And feel free to kind of reach out if any of these is of interest. In fact, we are also looking for more people, research scholars and so on for this project. And data ecosystems promises to be a very interesting topic, especially given that in India we are going in full steam in this area, especially with mobile transactions. Already India accounts for more than 40% of global mobile payments. So that's the rate at which we are growing. We have surpassed US, China, every other. So given this, data ecosystems and digital intermediaries is likely to become more and more important in the coming years, and definitely consent management would be a core issue in that. So it's a very exciting area to be in, and a lot of very interesting discussions we keep having around consent.
Thank you very much, sir. Again, all the participants, thank you very much for your very active involvement in the last 4 days. So tomorrow we have 2 more talks scheduled. So we started off this whole summer school with introduction to cryptography, and then we went into the mathematics of the homomorphic encryption and secure multi-party computation, and then we went into the social aspects of it, the legal aspects also, the taxonomy, and today we talked about the abstraction of role-based and content and basically the various different abstractions of the privacy of data. So tomorrow we will look at applications, the real-world applications of these things, and then it will be really very interesting talks by 2 different separate implementations and applications in this area. So we look forward for your active participation. See you tomorrow. Thank you. Bye-bye.